All right, let's take a look here. I put it over there. Let's take a look at these. All right, you didn't expect to be talking about women's bone density, but here we are. If we randomly selected one, so I know that the mean is 2.9. Standard deviation is 0.71. We know they're normally distributed, that's why I could do part A. If it didn't say this, a sample of 38 would be good enough, right? It's got to be at least, or more than 30, and then I can do stuff. Up here, I know it's normal, so I don't need 30. I can do anything. Draw my picture. What goes in the middle? 2.9. I'm curious about 2.5. I want more than that. So this is how you be nice to yourself. Tell yourself where the answer is. So now I make a z-score. I've got everything I need for the z-score. My data point minus the mean divided by the standard deviation for individuals, because I'm only talking about one woman. I think you guys are getting negative 0.56. So this is negative 0.56. And when I look that up, the area I get won't be the answer. But what area do you guys get? 2877? So then 1 minus that is going to be the answer. So what do you get?
7123.
Yep. Cool. All right, so part A, that's a chapter 6 problem. We didn't have to adjust anything because I was talking about one woman. Part B, a group of 38 women. What's the probability that their sample mean? Look how nice I'm being at the moment. Bolding that thing, saying, look, this is a trigger. Not meaning you go crazy, but that's a trigger to change the standard deviation. It's going to be the same work. I still need to do a z-score to find the probability, but I can't use this because that works for one woman at a time. I need the one that works for groups of 38. So the very first thing I want to do is change this silly thing. Square root of 38. So what do you guys get? 115? Okay. So if you go more than 3 places, that's beautiful. You have to go at least 3 places for standard deviation. That is not, I saw a few people doing 0.11 and looking it up on the chart. That's not a z-score yet. You've told yourself, you were nice to yourself again. You told yourself what the hell you're doing. That is a standard deviation. Can't look that up on the z-score chart. I got to make a z-score to look that sucker up. So got my same little picture. 2.9, 2.5, we want the area above it. But when I go to make a z-score now, I'm going to divide by 0.115. What do you get?
Minus 3.48.
So see, it's the same work. See that? It's the same work. You can see that. Because it's basically the same question. It's just part A's question is about one woman. Part B's question is about 38 women. It's the same question, though. But I know what happens statistically. The picture changes, so I have a different spread. But the question is still the same. I still got to get a z-score. Look up the area to get the probability. Okay. So when I look up negative 3.48, what do you get? So then the other side be point.
9997.
Beautiful. So almost 100% chance. Which kind of makes sense. If the average is 2.9 and I take 38 women, their bone density should be close to 2.9. So it's greater than 2.5. Well, it's going to be almost impossibly less than 2.5. Now let me try to push this a little bit. Right. These are correct. Decently correct. I can't remember when I think it's within the last couple of years. I don't think bone density has changed suddenly. You never know. If I did take a sample of 38 women from some certain area, and I found their bone density to be an average of 2.2, what does that mean? What could that mean? Is it likely to happen?
Yes.
Let's try this again. It's probably it's greater than 2.5. almost 100%. It's probably less than 2.5. 0.03%. So if I go to somewhere and I take a sample, so this is sort of like, you remember, you guys ever seen Aaron Brockovich, that movie? I know it's a little old, but back then. You never heard this? You ever heard PG&E? And they were contaminating the water. And there were families getting cancer. So part of what they had to do was a statistical analysis to show that it was unlikely that the cancer would just naturally happen like the way it did, that it had to be caused by something. So if I go somewhere, there's like a complaint. The water tastes funny and I don't feel good. All right, let's go out there. And I look at women's bone density. Just because I'm like reaching, I don't see anything. I'm like, what the shit's going on? People are getting a lot of bones breaking. I'm like, oh crap, let's look at their bone density. And I get an average density from 38 randomly selected women of 2.2. How likely is that to just naturally happen? Almost freaking impossible. So what is it evidence of? Something is causing their bone density to be different than what I expect it to be. That is the immediate use of this kind of analysis. The actual analysis you would do in real life, you got to understand, this is a little bit simplified, but not that much. It's not that far away from this. This is basically what's done. That doesn't prove anything, but it's sort of like your DNA matches the DNA found at the scene. Is that 100% that was you? No, but it was freaking you. Holy crap. You combine that with all the other shit, that was you. Get out of here. All right? Maybe if the glove doesn't fit, that's not good enough, but... Oh, yes.
Let's say because I rounded the 0.115, and it just basically got 0.001 up or below the answer.
Whoa.
On the test with that.
Wait. What'd you use here?
I used 0.12.
Oh, that's bad. And you see why now. That actually changes the answer a lot. So that's why I say at least 3 places on standard deviation. So you would lose not a ton of points. It's like grade on, do you understand the process? But you would lose like a point or something. Yeah. Okay. You're like, well, shit. Okay. So down here, the first 2, I'm just taking 1 infant. So that's chapter 6. What goes in the middle?
79.
So here's 79, somewhere over there. I want less than, which is nice. That's what the chart tells me. So if I make that into a z-score, here's the standard deviation. What'd you guys get for that?
Minus 0.86. 0.09.
Yeah, it sounds right. Yeah, it should be roughly 1/10 negative. So negative 0.09. And then when you look that up, what area do you get? Okay. So a 46% chance that an infant born down in Florida will live to be less than 79 years old. You guys with me? Life expectancy actually dipped down for the first time in forever recently. America. All right. This guy, same idea, except now I just have 2 z-scores to make. I want the area between these 2. So I got to find the area, the big area minus the small area to get the area in the middle. So if I make 71 into a z-score, what do you guys get? The 1.14. And then if I make 62 into a z-score.
Negative 2.3.
Okay, sounds about right. You look at those areas. What's the big area?
0.1271.
1271? That looks confusing. Oh well. And this was point.
0.0099.
All right, let me stop for a second. So it's exactly like this problem. It's just 2 z-scores to look up instead of 1. So make both of these data points into z-scores. Look up the areas, and now I just subtract them, right? So I get 1 point. Yeah, 1 point. 0.1172. Okay. Okay, cool. And then here's the new stuff. So what's the very first thing I want to do on this one?
Standard deviation of the sample.
Yeah, so take the old standard deviation of 7.6 and I divide it by the square root of 87. I make it become the spread of groups of 87 instead of groups of 1, right? What do you guys get for that, sir? 185?
No, 8.5.
Who? Do it again?
0.815.
Oh, 0.815, okay. You guys are like protecting your numbers. Like, just note my number. So then I want 79.7, I want less than 79 years. So I make a z-score the same way we did before, but now I use 0.815 down here. I don't know, what's that going to be?
Negative 0.86.
Negative
0.86.
0.86? Okay. And then when you look at that z-score, what do you get for the area?
0.1949.
Sounds about right. So it went from 46% chance to a 19.5% chance. Because where are most of them going to be? They're going to be closer to the mean. When I take a sample of 87, the actual picture becomes like this crazy skinny thing. 87 is a pretty big sample space. That's why it went down by quite a bit. Most of them are close to the mean, so there's less left out in the tail. Okay. That's good. We can leave. That's as much as I wanted to do. You're all like, yeah, more than I wanted to do, Jeff. All right. So don't forget, Monday quiz, chapter 6.